basically if I look into, so that is used as far as computer network communication is concerned is the TCP. Very good. Application layer. First one is application layer. So next stack, which is used in real time. Okay, where no session, no presentation layer is present, but the functionality of the session layer and presentation layer has been clubbed into the application layer. Okay, so next to transport layer,
Network.
next to network is data link.
Link layer.
Finally, physical layer. Generating message. This is the first and foremost important job of a application process. That is the job of a application layer. Transport layer being demultiplexing. Because these are the very important concept I have to understood. This is the basics. Once you understood the basic, then we start with, so we don't have any problem. You can able to visualize routing of packets. So routing is decided, route is decided for a particular packet in the network layer. So then data link layer, hop to hop. So data transfer is happening in the data link layer. Then wire medium may be a wireless medium. But in order to do so, it has to first convert my bits into signals when sending. Because so physically my data is stored inside a computer in bits, binary values. So but that has to travel in the wire in terms of electromagnetic waves. So there needs a conversion from bits to what? So between processes, one process is generating a data, another process is going to consume the data or receive the data. So this kind of scenario is called as process to process communication. Try to understand this very, very clearly. Very important concept. So communication always happens from one process to another process. That means one process will generate the data, another process is going to consume the data. It is neither the computer nor the router. Ultimately, one process will send, another process will receive. If there are no two processes available, then no communication can happen. Try to understand this very clearly. Okay. So this kind of communication is called as a process to process communication. And this process to process communication is facilitated by the transport layer. That means earlier I talked about, so transport layer functionality is only multiplexing and demultiplexing. Now I'm adding one more functionality on top of it. That is process to process communication. That means transport layer facilitates multiplexing and demultiplexing of packets. At the same time, it also facilitates process to process communication. Understood this fast? So next, once I have process to process communication, मान के चलिए you want to send so a packet from process P1 to process P4. In order to do so, what I have to do? I have to send the packet from so source host to the destination host. अरे अगर मेरा पैकेट मेरा प्रोसेस से उस पैकेट प्रोसेस तक जाएगा, पहले मेरा कंप्यूटर से उस कंप्यूटर तक जाना है, उसके बाद उस कंप्यूटर के अंदर so it will be decided so to which particular process the packet will be delivered. Just think of the post office postman and so office boy. So if I want to get a letter, okay, so somebody sending a letter, somebody is going to receive a letter, so those are process to process communication. But in order to do so, first of all, the process, the letter has to be received at the hostel office boy. अगर ऑफिस बॉय आपका so letter receive नहीं करेगा, तो you cannot able to receive your letter. So first of all, the communication has to happen between the postman and the office boy. So then only he could able to get your letter. Similarly, in order to achieve this process to process communication, first of all, my message has to go from the source machine to the destination machine. So that's why, so this is called as host to host communication. That means in order to facilitate process to process communication, I must facilitate first host to host communication, or in other words, we must facilitate host to host, or that is called end to end communication. So then who takes care of it? The next layer. So that is along with this, so routing of packet, so this also so facilitate host to host communication. In other words, we call end to end communication. That means now what I understood, network layer not only route the packets, but by that, so it also facilitates host to host communication or end to end communication. Okay, now in order to facilitate host to host communication, agar mera letter, so I'm sending from Bhubaneswar to Mumbai, So ultimately, first my letter has to go from Bhubaneswar to so Mumbai, so maybe railway station. Then Mumbai railway station to so it is going to go to the post office box of respective so destination. So that's why you know to go the letter from one host to another host. First of all, it has to go from this machine to the router. From this router, it has to go to so this destination. So in order to facilitate host to host or end-to-end communication, first of all, my packet has to go from the source machine to the router R, and then from router R again to show this. So next destination, so that is final destination D. So what is this? This is nothing but hop to hop. This is nothing but hop to hop. So in order to facilitate host to host communication or end to end communication, so what we need to do? We need to facilitate hop to hop communication. So that is from S to R or from R to D. So that's why that is taken care of by whom? By the data link layer. That means now we try to understood clearly what is a process to process communication. Port number. Every process is uniquely identified in a computer network communication by using a port number. Very, very important. Everybody please understood this. By using a port number, a process is uniquely identified. So that's why this process to process communication happens or facilitated by use of the facilitate this hop to hop communication or end to end communication. IP address is used for so segregating the packets. IP address is going to use for routing the packets or for making a communication from one host to another host by using a network layer. So similarly, transport layer uses this port number information to distinctly so make a communication from one process to another process. Okay, so MAC address facilitates this hop to hop communication, and that is used by the data link layer so to make this communication possible. Later on we'll so understood the detail of it, but for the time being you must have the concept in your mind. That means port number, by using the port number, process to process communication is facilitated. So by using the port number, this process to process communication is facilitated. By using this IP address, this host to host or end to end communication is facilitated, and by using the MAC address, this hop to hop communication is encapsulation or decapsulation. What is this? Encapsulation and decapsulation as far as this computer network communication is concerned. Very, very important to understood this. Okay. So now, so as I have already told, every system, so whenever I say has to have the TCP/IP stack to make it communication possible. So starting from the top, at the top it is the application layer. So going next is the transport layer. Going next is the network layer. Is the data link layer. So finally is the physical layer. Physical layer. Okay. So this we have already understood. Now, so whenever, so we say we start the communication, actually how the communication happens, let's try to understood. What the application layer does? Application layer generates the message. Okay. So, and after generating the application layer, the message, what it is going to do? It is going to, if I want to send a packet from my machine to some other machine, what is ultimately going to happen? So the message is going to be generated at the application layer, and then, so it is going to be sent to the transport layer. Okay. So what is going to send? The message is going to send. Understood this communication very clearly. So then what happens? So when the message received at the transport layer along on top of this message, he is going to add its own header, that is a transport layer header. So remember that whenever you are sending a packet from so one layer to the next layer, always a header is being added. What is a header? So header is nothing but certain extra information. Let's say for example, so you are sending a letter to your friend. So what you are doing, you are writing the letter. So then on the top of the letter, you are writing his name, you are writing his address. So these are not the content of your letter. These are the extra information you are putting for making this communication possible. Yes or no? So on top of the message content, you are writing the address, name of the recipient so that the letter can be delivered to him. But these are not the contents. Similarly, so only generating the message is not going to help my communication to possible. So along on top of it, I have to go and add some extra information on top of it to make this communication possible. So that's why every layer goes and adds some extra information, and that is nothing but called as header. So as far as the communication is concerned, okay. So that's why when the message has come from the application layer to the transport layer, on top of the message, the transport layer has added its own header. So then, and that is called as a segment. That is in computer network is called as a segment. That means segment is nothing but application layer message plus transport layer header. So now the segment is going to given to whom? To the next layer. That is the network layer. Okay. So again, what network layer does? Network layer receives what? The application layer message and the transport layer header. So on top of it, what it is going to do? It is going to add its own header. That is the network layer header. Okay. So, and that is referred as a datagram. In computer network, we call it as a datagram. So then the datagram is going to be sent to the next layer. That is the data link layer. It's sent to the next layer. That is the data link layer. So then, so data link layer, after receiving this datagram, that is nothing but message plus transport layer header plus network layer header. Then on top of it, it adds its own so header, that is the data link layer header. Okay. So that becomes a frame. That in technical term, in computer network, we call it as a frame. And that frame is ultimately going to give it to the physical layer. So once physical layer getting this frame, so that is in terms of bits, it is going to transmit it or sorry, convert it into so the corresponding signal, and physically it is going to send the data. So out of this device to somebody else by using the NIC card. So this what happens. So during the sending of a packet. So during the sending of packet, what I'm doing? I'm adding headers. At every layer, the header is added. Here transport layer header is added. Here the network layer header is added. Here the data link layer header is added. That means every layer during the transmission of a packet add its own header to make this communication possible. And this process is nothing but called as encapsulation. This process is called as encapsulation. Adding headers on top of so the received information is called as an encapsulation. Similarly, let's look into, so while I receive a data, so I receive a data at which layer first? While sending, I start from application layer. Similarly, signal. So from the other end, I receive the signal. Then the physical layer is going to convert the signal into bits and give it to the data link layer. So what it gives to the data link layer? That is the frame. After converting the signals to bit, it got the frame. And now, so physical layer send the frame to the data link layer. What is there in the frame? So now, what the data link layer is going to do? So data link layer is going to remove its own header. Okay. And what remains? So after removing the data link layer header, now data link layer is going to give the datagram to the network layer. Getting my point? So what is there in the datagram? It is the application layer message, transport layer header, network layer header. Yes. So now what is going to happen? So network layer is going to remove its own header. That is the network layer header information. Okay. So then what? That is nothing but the segment. So now transport layer got the application layer message plus transport layer header. So then it removes its own header. That is the transport layer header. What remains? Message. So transport layer now gives the message to the application layer. So application layer got the message only. Okay. So this way, if I look into this way while receiving the packet, what I'm doing? So just removing the headers, and that is called as decapsulation.